In this video, we'll talk about cross product, and I'm going to go over a few definitions that are important. First of all is the cross product, the magnitude of the cross product u times v, and this x shows that we are talking about cross product, is the magnitude of u times magnitude of v times sine of theta, where theta is the angle between the vectors u and v, and theta is between 0 and pi. The other formula is where we multiply or we find the cross product of coordinate unit vectors. So I, j, and k. And I like to write them in this order because now it's very important as we go. I cross product j gives us k. Because as you can see, j cross product I is negative k. So it's exactly the opposite. The multiplication, the cross product is not commutative. J cross product k produces I. K cross product I, it's j. And they are written here, 1, 2, 3. Also, the opposite, k cross product j is negative I cross product k is negative j. Also, I cross product I equals j cross product j equals k cross product k equals 0, because I cross product I is the magnitude of I times magnitude of I again, which is 1 times 1, and sine of 0, it's a 0. So the magnitude of I times I is 0. The magnitude, and here I have magnitude of I equals magnitude of j, magnitude of k equals 1. Another formula that it's important is when the vectors are written in using their components. So u1, u2, u3, and then v is v1, v2, v3. If we want to find the cross product, and this time we don't find the magnitude, we find the cross product, it's a determinant where on the first row we put the coordinate unit vectors. On the second row we put the components of u, and on the third one we put components of v. So calculating this determinant, and if you remember some rules of calculating determinants, we can say is I times the determinant made when we cross the column of I and the row and the column of I. So what is left, it's a 2 by 2 determinant, u2, u3, v2, v3. Then minus, then we write the determinant that we obtain by crossing out the row of j and column of j. So here we are left with u1, u3, v1, v3, and then plus, and now we write what is left after we cross out the column of k and the row of k. So we are left with u1, u2, v1, v2. So by calculating these determinants and writing the coordinate unit vectors I, j, k, we can find the cross product. And we notice that when we find the cross product of two vectors, we end up with another vector. And another one, area of a parallelogram with two adjacent sides. So if I have this and these are two sides, u and v, then if we do the cross product between u and v and find the magnitude of that, we are actually calculating the area of this parallelogram. So let's take a look at a few examples. So we have u, vector u, which is written in component form 2, 0, 0, or 2i, v of 0, 3, 0, 3j, and we want to find u cross product v. So I'm going to draw this in the 3D just so to see how they look like. So I draw a coordinate x, o, y, z. U is 2, 0, 0, so this would be u. V is 0, 3, 0, so this would be v. And we want to find out u cross product v. Let's say we want to find out the magnitude of u cross product v. So the magnitude of u cross product v is equal to magnitude of v times magnitude of u times magnitude of v times sine of theta, which is the angle between the two of them. Magnitude of u is 2, magnitude of v is 3, so then we get here 2 times 3 times sine of theta. The angle between these two is the angle between the x-axis and the y-axis, so it's 90 degrees, so sine of 90 degrees. So we end up with 6 times sine of 90 degrees is 1, so we end up with 6. So the magnitude of the cross product, it's actually 6. But if I were to locate it in the coordinate plane, well, because this is I and this is J, the cross product would be K, and then we know that it's 6 units, so this would be the vector u cross product v. So it would be basically 6k, because these two are 2i, 3j, right? So we are doing 2i cross product 3j, 2 times 3 is 6, but I cross product j is k. So we located the cross product and we found its magnitude. Let's take a look at another problem. Basically, this is the same problem, but I want to solve it in a different way. So we did u cross product v, we located it, but not all the time is that easy to find it. So in order to calculate this, I'm going to use the formula. So I, j, k on the first row, and then 2, 0, 0, the vector u, and 0, 3, 0, vector v. So in order to calculate them, we go by I, and then if we cross out the row of I and the column of I, we are left with 0, 0, 3, 0, the determinant, minus another determinant, j. So minus is from the formula. So first one is with plus, the second one is minus, and the third one is plus. So with j, we put, if we cross out the row of j and the column, we end up with 2, 0, 0, 0, and then plus, and we do the k. So cross out, we end up with 2, 0, 0, 3. So the first determinant is 0, 0, I is 0. The second determinant is 0, so we get 0j, and the third determinant is 2 times 3, 6k. So if you have to review 2 by 2 determinants, it's equal to AD minus BC. That's the formula, AD minus BC. Order, it's important. So if we compare the 6k that we got in the second problem with the 6k that we got in the first one, we are right. We did it correctly. Now find the area of triangle ABC, where A has the coordinates 1, 2, 3, B has the coordinates negative 2, 1, 3, and C has the coordinates 0, negative 1, negative 3. So knowing this, we can find that vector AB, using the information from previous lessons, is negative 2 minus 1, right? So I'm looking at these two, and we go u2 minus v2, v1 minus u1 if you want, and so on. So we get So let me explain that a little bit better. So if this one is U1, U2, U3, and B is V1, V2, V3, maybe I should put coordinates, then AB would be V1 minus U1, V2 minus U2, and V3 minus U3. So it's going to be -3, -1, 0. And to explain that, why we subtract, I just made here a quick sketch for a 2 by 2. So in order to find the x coordinate, we would do this distance, which is V1 minus U1. To find this distance where AB extends would be V2 minus U2. So then we extrapolate it to 3 by 3. Now, I want to find AC, the vector AC. So the vector AC would be 0 minus 1, -1, -1 minus 2, -3, and -3 minus 3, -6. So we found the vectors AB and AC. So if we have the triangle ABC, then this is what we just found out, right? So that's gonna help us. Now we know that if we calculate AB, the vector AB, cross product vector AC, and if we do that in magnitude, we are actually calculating the area of this parallelogram. This is what we are actually calculating by doing the cross product of AB times AC. So in order to, I'm going to calculate this, but because I want the area of a triangle, I'm going to do half of that. So let's calculate first the cross product using the determinants I, j, k. So AB is -3, -1, 0, and AC is -1, -3, -6. So we calculate this, which gives us I, we cross out, it gives us, well, actually I can even calculate them by looking at, right, if we cross out this and we cross out this, we end up with -1 times -6, that's 6i, because the other diagonal is 0. Minus, let's put j, and let's see what's in front of j. So I cross out j like this, and I end up with -3 times -6, that's 18, minus 0, so that's, again, I don't need it. And then plus k, well, if we cross out the k and the column and row, we end up with -3 times -3, that's 9, minus -1 times -1, that's 1. So we ended up with 6i minus 18j plus 8k. So let's calculate the magnitude of AB cross product AC. That would be square root of 6 squared plus -18 squared plus 8 squared. So we end up with 36 plus 324 plus 64. So that is square root of 36 plus 64, that's 100. So 424, which is square root, like we did, 4 times 106, which is 2 square root of 106. So the area of the triangle, it's 1/2 AB cross product AC. So it's 1/2 times 2 square root of 106, which is square root of 106. And we can round it to 2 decimals, and using the calculator, square root of 106 is 10.3. And we solved it.